Have you ever stopped to think about something that's literally all around us, all the time, but we can't actually see it? Well, today, we are diving into the absolutely incredible science of light.
I mean, really think about it. You flip a switch in your room at night and boom, everything's just gone. So why is that? What's the secret ingredient that lets us see everything from our TV screen to our best friend's face?
You guessed it, the hero of our story today is light. Without it, our world would just be, well, dark. Light is the special kind of energy that lets our eyes see the amazing, colorful world that's all around us.
Okay, so what exactly is this stuff we call light? To get to the bottom of that, we first have to figure out where it comes from. And it turns out, pretty much everything in the universe can be split into two teams when it comes to light.
This is where it gets really cool. So on one side, you have the light makers, or as scientists say, luminous objects. These are the rock stars, the sun, a flickering candle, a light bulb. They make their very own light. But then you have the light bouncers, the non-luminous objects. And that's, well, almost everything else. Your chair, a book, the moon, even you. We can only see these things because they're bouncing light from a light maker into our eyes.
So we know where light comes from. But how does it get from, say, a lamp all the way to your eyeball? Does it do a little zigzag dance? Does it wiggle around? Nope. Light plays by one very, very simple and super important rule.
It's called rectilinear propagation. Whoa, that's a mouthful, right? But don't let the big words fool you. All it means is that light travels in perfectly straight lines, always. It can't just decide to bend around a corner. Just picture a laser beam shooting straight ahead. That's exactly how all light travels.
And you can actually prove this with a super simple experiment. Just imagine you take 3 pieces of cardboard and you poke a little hole in the exact same spot on each one. If you line them up perfectly with a candle on one side, you can look through the holes and see the flame. Easy. But the second you move even one of those cardboard pieces just a tiny bit, poof, the light is blocked. You can't see it anymore. It's the perfect proof that light needs a straight path to get anywhere.
All right, so we know light travels in a dead straight line. So what do you think happens when something solid gets right in its way? You get something we've all played with a million times, a shadow. You know, making a shadow is kind of like baking a cake. You just need 3 ingredients. First, a source of light, like a flashlight. Second, an opaque object, which is just a fancy word for something solid that light can't go through, like your hand. And third, you need a screen to see it on, like a wall. That's it. Light, blocker, screen. You've got a shadow. But have you ever looked really closely at a shadow? You might notice it's not just one big dark blob. It actually has 2 parts. The super dark center is called the umbra. That's the dark heart, where the light is totally blocked. But around that, you see those fuzzy grayish edges? That's the penumbra. That's where some of the light is blocked, but a little bit can still sneak around the sides.
Okay, so we're masters at making shadows with our hands now. But what if we scaled things up? I'm talking way, way up. What if our light source was the sun, and the object blocking the light was the moon itself?
We've all heard of eclipses, right? They seem like these huge, magical events in the sky. But what's really going on up there? What are they?
And here's the big secret. They're just shadows. That's all an eclipse is. It's the exact same science that makes a shadow puppet on your wall, but it's happening on a massive cosmic scale. It's just the moon or the earth getting in the way of the sun's light. So, a solar eclipse happens when the moon passes right between the sun and us, here on Earth. When that happens, the moon's shadow actually falls on our planet. And if you're standing in that shadow, it looks like nighttime in the middle of the day. The key alignment to remember is sun, then moon, then Earth.
A lunar eclipse is just the opposite. That's when our planet, Earth, gets right in between the sun and the moon. Our whole world casts this huge shadow right onto the moon, and it often makes the moon turn a spooky, reddish color. So for this one, the alignment is sun, then Earth, then moon. Now listen up, because this is the most important part. Even though it's amazing to see, you can never, ever look directly at a solar eclipse with just your eyes. You need special protective glasses. The sun's rays are so powerful they can permanently damage your eyesight. So please, always remember, safety first. Whew, we've covered a lot, from a simple light switch all the way to the moon blocking the sun. It all boils down to just a few key rules. So let's do a quick recap with our light cheat sheet.
All right, here are the 3 big takeaways, your new superpowers. Number 1,
Light is how we see everything, and it always travels in a straight line. Number 2, a shadow is just a place where that straight traveling light is being blocked by something. And number 3, those awesome eclipses, they're just giant shadows playing out in space. See, it's not so complicated after all.
So there you have it. You're officially a light expert. The next time you see your shadow stretching out long in the afternoon or watch sunbeams stream through a window, you'll know the incredible science that's making it all happen. So go on, take a look around you. What amazing things will you notice next? Thanks for joining this explainer.